Let me introduce you to the greatest triangle of all time. This is called the Great Triangle of Science. Science. Density is equal to m over v. It is the tool that I will use to answer all of these questions. Let me show you how it's done. Any question involving density, I immediately write down the great triangle of science. Science. D is equal to m over v. If they give me mass like this, I circle it. If they give me volume like this, I circle it. If they ask me for something that's in that triangle, I scratch it away, leaving behind what to do. M over V. See that? See that? M over V. 22.7 grams divided by 2.0 cc's. Let me call on you. All right, Alex, what is it? 11.35. Are you sure? G. What about this? G times cc or G divided by cc? Divided by cc. See how that works? G divided by cc. Why? Because those units are left over. G over cc is left over. Any questions? All right, let me do another one for you. We're going to skip 18 because you guys are going to do 18. I'll do 19. You ready? Let's see. Oh, I see the word density. The great triangle of science. Science. D m over v. Density is equal to m over v. A piece of lead occupies a volume. So I'm going to circle volume. What is the mass? Scratch away mass. Density is circle. So what's left in my triangle? D and V. So all I have to do is multiply. Do I have a unit that's the same in the numerator and in the denominator? Yes, so I cross them out. 11.4 times 4.0. Genesis. What's the answer? $11.4 times 4.0. What? Very nice. Very nice. I'm going to skip. I'm sorry. Any questions on how to do this? I'm skipping 20 and going straight to 21. Blah, 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 blah. Oh, density. The great triangle of science. Science. 302 grams. I still think it's amusing, and I've been doing it for 30 years. It is. Mass, what is the volume? Scratch away what is its density is. They give us density. That tells us what to do. It's M over D, right? Do you see that? M over D. Mass is 302 grams. Volume is 11.4 grams per milliliters. Now, this is a little confusing to me. This is a little confusing because I have a denominator in a denominator. What has your math teachers taught you that really means? That means that the denominator in the denominator becomes part of the numerator. And that allows this to work. Because do I have a unit that is both on the numerator and the denominator at the same time? Maximus? I don't know if I forgot to give you your notes. See, you're not doing much. Have a good thing. All right. So, what is 302 divided by 11.4? And the answer, all that's left is ml. Let's see, Daylin. Anybody disagree? You disagree? You're good? You got the same answer? Everyone's calculating, right? Yes, sir. All right. Who would like to do number 20 now? Raise your hand before I volunteer you. Destiny. I mean, your name is basically density, just misspelled. Let's do it. Oh, I see the word destiny. So what do I write down? This is, you need to write down what amuses Alex every time we write it down. Okay? How many compartments? Like that? And what goes in each compartment? What goes, where does mass go? Okay, so if they give me volume, what do I do with the triangle? No, if they give me volume, what do I do with the triangle? Either circle or scratch. Circle what? Okay, they're asking for mass, what do I do? Circle or scratch? Scratch. And if they give me density, what do I do? What? Well, circle. Okay, and what's left over tells us what to do. She's a little ahead of us, isn't she? D times V. So what is density? Try again. What is density? Per. What is volume? What do we do with our units? Keep them or cross them out? What is 8.93 times 4.0? $35.72 grams. Anyone disagree? Jacob Kesterson. Do 18. Oh, I see the word density. What do we do? The great triangle of science. Okay, how do we inhabit this great triangle of science? All right, good. So they're giving us mass. What do we do with the mass? Okay, hold on. One thing at a time. Mass, what do we do with our triangle? Circle or scratch? It occupies a volume, so and they want density. That tells us what to do, doesn't it? What is it? And what do we do with the units? Can we cross any of them out? So they are transferred over. What y'all think? Which one did we miss? Number, what? You have a question about this one? Which one did we not do? Which one did I skip? 22. Let's see, somebody, Junie, a piece of land. Is it your birthday? Happy birthday, Junie. Yay. How old are you today? Still 12. Okay. All right. Mass. So what do we do, right? We see the word density. What do we write down, Junie? Science, science, science. The great triangle of science. And where do we put all the letters? Okay, I give you mass, circle or scratch. I ask you for volume, circle or scratch. I ask you, I give you density, circle or scratch. So what do we do? M over D, 200. Uh-oh, I'm confused, Junie. I have a milliliter in the denominator. I have a denominator in the denominator. That's confusing. So what do I do? Move it. A denominator in a denominator is a numerator. Okay, so do we have units that we can cross out? What is 200 divided by 8.93? Anybody disagree? Good job. There are just 3 kinds of questions here, gang. Can you do them now? We'll hope. We'll hope. All right. So, density. The most dense solid element is gold. The most dense liquid element is mercury, by the way. Has anyone ever played with mercury? It is not explosive. It is not explosive. It is very dangerous. If it gets into your system, it can wreak havoc. Okay, I used to play with mercury. Can't you tell? All right. Should not play with mercury. Now, I always try to give you a practical curve to everything, right? Density in water is extremely important. This fall, I will take out my caulk gun and I'll load it with liquid concrete. And I'm going to go on a mission. The mission is to look for cracks on my sidewalk, not the big crack. The big crack I leave alone. I'm talking about little cracks on my sidewalk or my retaining wall. Why? We shall see. Can anyone rank for me the phases of matter when it comes to density, how close they are together, from solid to gas? Who can do that? Raise your hand. Say, blah, blah is the densest, then blah, blah, and then blah, blah, blah. Thank you, Matthew. Kelly, yes. Who is the most dense? Solid and liquid, then gas. And you would be correct 99.9999999% of the time. Okay? So you've got a 99.9999% accuracy rate. The one exception that I can think of to all this is water. Why is water an exception. Every time you put water, you put ice in water, you see it being an exception. Why? Who can do the three phases of matter for water, starting with the most dense? Oscar, ice is the most dense, solid? Ah, if it did, guess what would happen to the ice when you dumped it in water? It would sink all the way to the bottom. Try again, Oscar.
Water.
Liquid, then ice, then gas. That makes all the difference in the world, folks. Why is it so important that water is more dense than ice? Because that means that when it's wintertime and it's freezing outside, the ice is going to form where? On the top and not on the bottom, which would be very, very bad. Because where does the food cycle begin? In the water, at the bottom. So what if you freeze the food? What happens to all the little fishies? They die. And what happens if the little fishies die?
The big fishes die.
And what happens if the big fish die?
The bigger fish.
Then the land animals die. And what happens if the land animals die? We die. Everyone dies. Death, death, death. Isn't that an amazing picture?
Yes.
Not sure it's real, but I still think it's kind of amazing. That's what it would look like, though. That's what it would look like if it was real. So, how does nature of density cause erosion? Have you ever been driving up through the mountains during the winter months? You look on either side, and what do you see? You see snow, but more importantly, on those cliff walls,
You see like
chains, stalactites, ice just frozen on the rocks, right? What if those rocks had a crack and it rained and the water got inside? So water is more compact. Water can fit into tiny little places. So what happens if the water gets in and then freezes? How powerfully can, when water expands, what can water do to those cracks? Watch this video. They're going to take a grenade that has been made safe. They have removed all the explosive from the grenade. All that's left is the metal shell. And they're going to fill it with something that is safe, like water. Watch what happens.
The ice bomb illustrates the fact that the volume of ice is greater than the volume of an equal mass of liquid water. Some cold water is poured into a cast iron bomb, and a threaded plug is screwed into the bomb so that the bomb is tightly sealed. The bomb is then placed into a dry ice acetone slush, which is at negative 77 degrees Celsius, and will cause the water inside the bomb to freeze. A wooden box is placed over the top of the bomb and slush bath. It takes a short time for the water to freeze. When it does, the bomb explodes. Some of the dry ice acetone slush is blown onto the explosion shield. Little bits of the cast iron bomb are left. When the water freezes, tremendous pressure is produced. The pressure is enough to cause this cast iron bomb with more than 1/8 inch thick sides.
That is amazing. I thought I removed all the explosives out of it. Did I? Yeah, we filled it up with water. Can anyone explain what happened? Raise your hand. Somebody besides Oscar, because he's already answered today. Thank you, Wesley. You don't know? Okay. Yes, sir. Byron. And how powerful is that expansion process? Very, considering it shattered that 1/8 of an inch shell on that iron grenade. That's very powerful. Do you understand why the guy ran away after putting a wooden box to cover it? Okay? That could have been dangerous. That if that wooden box had not, and you saw the wooden box get shattered. If that wooden box had not been there, it could have that those pieces of metal could have flown through the air and could have killed somebody. So, question: why is it that in the late fall I take out my caulk gun and make sure that all the cracks are filled in that may have formed over the summer? Raise your hand if you can tell me why I should do this. Wesley. So what happens, a lot of times here in East Tennessee, we have what we call freezing rain, right? It just starts out with rain and it freezes. So what would happen if it starts out as rain? Can rain get into my little crack? Then overnight, when it gets super cold, what happens? That's why we get so many potholes during the summer. We get these roads, because of uneven expansion. We talked about the expansion of surfaces, right? Because of uneven expansions, they form cracks. And what happens when the rain gets into them over winter? Pop. What used to be a tiny little crack is now a huge crack. We drive over it, we make it even bigger. We may even pick up some of the pieces and sling the pieces around. All right.